Results now. Before we do the big reveal of the other children, let's go back to the question I asked you a couple seconds ago. I said go through your packet. We've already made our children, and you'll notice that each one of these traits. All right, so here's genotype. This is phenotype. So the genotype is the letter combination. Phenotype would be the actual description. So most of the traits when you drew them, you had two choices for phenotype, right? And so think about it like that. The round allele, square allele. You can have two squares and you're going to be two little r's and you're going to be square. That means you have two of the recessive allele. You can have two of the dominant allele and you'll be dominant, or a dominant and a recessive allele and you'll be dominant in this case. So what I asked you to do is find the cases where, in this packet, where it goes what's we call it going beyond Mendel. Like this. And I have it on the screen here, so let's do this. All right, take a look. Before we do that, let me just go back here, make sure we are recording. Okay, good. What's the difference between this and the other two? How many phenotypes do you have? 3. In this case, the heterozygous, the one that has one of each, has a third phenotype. Now, we're going to learn later that we don't write the genotypes that way for that particular pattern. Now, let's look at another pattern. There was actually 4 things that aren't regular dominant recessive. So what was another where you had more than 2 phenotypes? Eye color and hair color. So here's the letters. Now look at all these different genotypes and the different phenotypes. There's 1, 2, 3, 4, 5, 6, 7, 8 different phenotypes just with 2 allele pairs versus 1 allele pair. All right. Now, same thing with eye color. All right. Now, the last thing I want to talk about is there's certain genes that are on the same chromosome, and that's what this was trying to show, the linked genes. Remember nose tip? What you had to do is you had to, when you got over here, for nose tip, you had to flip it a second time to see if the size of the nose stayed with the size of the ear, or if you basically flipped these two. And that's what you did with nose tip. All right. So I think we kind of got the gist of it. Now it's time for our big reveal of all various classes. So this was the first one. All right, we'll put this back here. All right. Some of you could, well, let's look at, here's...
Wait.
All right, we're gonna. All right, so we had some ladies select a pile. This is not the one that they wanted me to pick. They definitely didn't want me to pick that one. All right, this one, I guess their parents decided to let them be free spirit and let them do their hair however they wanted. But let's go ahead and go to. I'm not going to show you the green lipstick, but all right. So here's one. All right, now this one drew theirs. Remember, you guys, every single time, we said it's got to be drawn to scale. So they did the scale, but what made the difference between that and, say, this one is this person put a lot more space in between the nose and the lips and gave them, like, I don't know, this looks like the former governor. Arnold Schwarzenegger. Yeah, I'm the governor. Okay, never mind. Okay, so that's some of the things that we saw. Let's go through this quickly because we want to finish. Here's some more from our class. Oh, okay. We already saw this one. Now this one got some interesting. Look kind of the face. You ever seen the movie Avatar? And the face is kind of. Okay. Now, one of the things that was asked when we did this, some students were like, well, what about pigment? Let's go back to this for 1 second. And, I don't want to make this too long of a video, but this is from a select gene pool. It's like representative of this. What they didn't put was color, or what we call skin tone, because that's like the hair and eye color, but even more complex. It's what's called a polygenic trait. All right? So it's, like I said, it's more complex. So if you look at this, see where you have, you got 2 allele pairs, meaning a choice of A's and B's. Add in like 4 more of these, like a C and a D, and that's what can contributes to what we call our ethnic characteristics of skin tone. It's a lot more complex. Okay, so let's kind of wind down. We got this one.
You got a movie star, man.
Yeah. Oh, wow. Wavy hair, dreamy. Okay, there we go.
That's what I thought looked like an
Okay,
orangutan.
again, so not every student decided to have pigment. We got this one here.
I see all right.
All right.
It's all
Very bright
right.
eyes. All right. Yes, you can hear the proud parents. All right.
Yeah, you can. Oh, God.
All right. Now, this is someone from 7th period. They actually looks very similar to the mom. I'm not going to show you the picture of the mom. Okay. Again, this is a simulation only. Okay. Again, you can see the spacing. All right. All right. We'll do. Okay. This one decided to make it into a caricature and give them a little tiny body. All right. This was a request that we put this one. Hey, all right. The genes you have are the genes you have. However, what you allow your child to do with your genes and hairstyle, and we've been around here seeing all the dyed hair. That's not a genetic thing. That's a cosmetic thing. All right. So let's go back to one of our first original ones, and very proud parent now. And, okay, and we'll finish with these two. All right, because the parent of this child has already decided that they're going to do some matchmaking with this one. Why is her hair so perfect? All right, let's try and get the. There we go. All right. All right, so that's our little variation of the face exercise.
That's not the match we had.
That's not the match you had?
No,
Oh.
Cole is supposed to go with Grace. She's prettier.
Oh, yeah, well, okay. What you're hearing in the background is students arguing over who gets to match up. Once again, this exercise has revealed a lot of the real-world behavior that we see.